Hi guys, welcome everyone. Here it says two identical conducting spheres are placed with their centers 0.3 meter apart away to each other. One is given charge 12 times 10 to negative 9 coulomb and the other one charge negative 18 times 10 to negative 9 coulomb. At the A it says find electric force exerted on one sphere by the other. So at the A it's asking what is the electric force. What about the B? At the B spheres are connected by conducting wire. After equilibrium has occurred, find the electric force between two spheres. First of all, let's solve the A, and it says what is the electric force. So formula of the electric force, K times Q1 times Q2 over R square, and K 9 times 10 to 9 times Q1, the first charge, 12 times 10 to negative 9, multiplied by second charge, 18 times 10 to negative 9, over the distance between them, 0.3 meter, 0.3 squared. When you do this calculation, you will get 216 times 10 to negative 7 Newton. That force towards each other, so it is attractive. They attract each other. This is the A. Let's solve the B. At the B it says the sphere connected with the wire, so it's like that. We have a sphere here, and if you connect them with a wire, so their charge gonna balance each other. That means both of the charge in the both identical spheres will be equal to each other. Firstly, we have to add them to each other. Charge of the first, it is 12 times 10 to negative 9 plus charge of the second, negative 18 times 10 to negative 9. So total amount of the charge here will be negative 6 times 10 to negative 9 coulomb. And then this value will be distributed equally for the both spheres. So it will be half and half. So negative 3 times 10 to negative 9, negative 3 times 10 to negative 9 coulombs for the both. So it's asking find the electric force again, but after conducting. Here is the negative. So it's asking again F is K times Q1 times Q2 over R squared. K, which is 9 times 10 to 9, multiply by, here in this formula we don't use the negative values, so 3 times 10 to negative 9, multiply by 3 times 10 to negative 9, over R square. R is the same because R does not change, 0.3 squared. So it will be 9 times 10 to negative 7 Newton force between them. But now they are both charged negatively, so the force between them will be repulsive force.